Hello all, welcome again. This video is the third video in the series and it is focused on chapter 3 of Unit 1. For those who are seeing this video for the first time, please also watch video 1 and 2 that are related to chapter 1 and 2 of Unit 1. Okay, let's proceed. And this chapter is about the topic called scoping. Before we see more details about this chapter called scoping, I would like to recap on last two chapters which we have seen in the last two videos. So the first unit was about function, and as we discussed before, functions are the basic building blocks of any programming language, and a function can have one or more subroutines. And a subroutine is nothing but a small code or a task which helps to achieve an outcome. For example, if you want to do an addition of 1 plus 2 is equal to 3, you can build a subroutine. So multiple functions form a programming language, and a programming language is actually built using the algorithmic statements as well. In chapter 4, you will see more about the algorithmic strategies and where I can give more examples about the algorithms as well. And when we talked about chapter number 2 in video number 2, it was more about data abstractions concepts. What is a data abstraction? It's nothing but a process of providing only the essentials and hiding the details. And data abstract normally allows programmers to treat code as objects. It helps to build a structure for a data operation in a computer programming world. As we go in more chapters of about Python programming, you'll try to understand more. Let's talk more in detail about now this chapter, which is scoping, in the next slide onwards. So in this chapter, there are 4 important topics we are going to discuss. First, the definitions and some examples around the scoping, and how do we use a LEGB role, which is an important concept too, and some points around what is a module, as well as a short brief detail around access control and how it's implemented in computer programming. Again, this chapter, while it looks more theory, it's also trying to give you guys details of the basic concepts used in computer programming. So what is scoping? Scoping refers to the visibility of variables, parameters, and functions in one part of a program to another part of the same program. For example, a scope of a variable is that part of the code where it is either visible and accessible. What does it mean? So in every programming language, when you write even a subroutine or a function, you will always define variables. Without a variables, obviously you cannot do a program. I come back to the same example I used to say, when you want to do an addition of 1 plus 2 is equal to 3, you definitely need variables to achieve that, as well as you need to do an addition operation. So if you don't do that, a computer programming language cannot understand what to do and give you the required output. In this case, answer is 3. So without a declaration of a variable inside a function or outside a function, you never can execute a program. In general, the duration for which a variable is alive, which is meaning it is active and valuable, and that duration is called lifetime. It's an important concept to understand. So lifetime is nothing but it's the duration for which a variable is alive. Now let's take an example here. When you assign a variable with colon equal to symbol to an object, normally a relationship is established. It's like an expression, to be honest. So, and this process of binding or relationship which is established is to a variable with an object is called mapping. It's important to know what is a mapping because you may get it in even two 2 marks questions too. So in the example, let me explain how an answer of 6 is arrived. So you're declaring a variable a with a value called 6. In this case, this 6 is a constant variable. And then you declared an expression or a variable b colon equal to a. So what you're saying here is whatever value a has, b will have it. So if a is 10, b also will have 10 in this example. And when you're printing b, obviously the answer is going to be the same as a, which is 6 here. So every time you change the value of a, the same answer b will get, which means the print answer will be the same. That's how you read this 2 liners of code. There is another concept they have explained in your book. I'm not sure it's clear, but I thought I'll give you some more details about what does a namespace mean. Again, all these are new terminology. You're going to, it may confuse some of you, but look, as per the book, they're trying to explain the basic concepts where possible, but sometimes they haven't gone in detail because they can't cover everything in a one unit or chapter. But it's important to understand the basics so that you will understand as you learn more about Python programming as well as anything related to computers in future. So the namespaces is a concept, nothing but they are containers of for mapping names of variables to objects. What does that mean? When you are mapping any variable, it has to store somewhere. It needs a space in the computer memory, and that space is called namespace. And namespace also helps to logically group things, meaning they are used to organize code into logical groups and also prevent name collisions that can occur, especially when your code base includes multiple libraries. So what the namespace beautifully does is it allocates a unique one location and for and a space for every variable you declare inside the programming language, and it makes sure there is no confusion when a function is calling a certain variable. It makes sure there is no confusion in giving the right value as well. A namespace also ensures that all of a given set of objects have unique names so that they can be easily identified. Why this concept is introduced here is it's very important to think in a way that okay, all these variables, expressions, all these is happening everywhere in a program, but without it stored somewhere, your computer program cannot how to say, after it runs and gives a result, it cannot store properly. So each and every variable linked to an object will be sitting in a namespace. Okay, and the last one on here I would like to talk about is LEGP rule. This is very important. This table is also important because using this rule, the computer decides the order in which the scopes are to be searched for scope resolution. What does that mean? So, as I said, variables can be declared anywhere inside a program, inside a subroutine or inside a function. And sometimes you may use the same variable name in different function. There are different ways of programming, as you all know. But the rule which is defined here, the L stands for local, E stands for enclosed, G stands for global, B for built-in, helps helps the variables to be correctly searched and then presented at the right time. So any variable which is declared in local means it's normally defined inside the function. What does that mean? Outside that function, that variable has no value, or it's dead really outside that particular function or class. Enclosed ones. Okay, so normally when you want to write nested functions, what is nested, and you have to do a looping programming or subroutines. Let's say you need to loop until 1 to 100 and keep adding 1 to 1 until it reaches 100. You can build a nested function. So in that kind of scenarios, you can also have some variables which can go into loop, like n is equal to n plus 1. That's called enclosed type of rule. And then in a global one, defined as the uppermost level. Okay, so this is also heavily used or commonly used in computer programming, where you can declare a variable, let's say t is equal to 0, and then you want the t letter to be any subroutines or subfunctions everywhere. When you call t, it will always return 0. So that's how it's declaration. When you declare like that kind of level out in the uppermost level of any program or a function, it's called global setting, and the global rule is used to retrieve value from that kind of variable. Built-in, these are reserved names in built-in functions. There are certain words in every computer language you cannot use as variables. I've seen some programming will say timestamp, for example. Timestamp is quite generic to a computer system, so it may not allow you to declare that as a variable and assign to an object. So those are standard words you can't use. So there's a little, but that type of words differs per programming as well. Okay, so anyway, it is important to memorize what is LEGP and memorize this table. It will help in your exams. Okay, let me move on to the next slide. Okay, there are 4 types of variable scope, because this is while we talked about scope in general, but another common terminology they use is variable scope. Obviously, we are talking about variables. And based on the LEGP rule, which we saw in previous slide, you can see local scope refers to variables defined in current function, which I explained before. And once if it doesn't find it there, the outer scopes are checked. So what happens when a computer programming is running a program automatically when you're implementing it, and then a variable is defined in a local scope, in the function, first it will check what value it has, and if it doesn't have it can't find that variable, then it will go check what is the next loop. So it will check, is there a global scope defined? So is that variable has a value somewhere else? So it will check for variables outside the functions in the program. And then sometimes, as I said, for the enclosed scope, it's a function within another function. It's called nested function, which I explained. A variable which is declared inside a function which contain another function definition within it. The inner function can also access the variable of the outer function. So this normally happens in functions with has got looping functionality, and quite common. This kind of approach of using enclosed scope is really common. So the computer program knows how to use the correct value and apply the correct answer and give the correct output as well. Last one I mentioned, built-in has all the names that are preloaded into program scope when a compiler is started. As I said, there will be standard library files in any software and standard variables and modules which will be inside the computer library functions. These are, when you say library functions, they're nothing but default computer functions already pre-built, like in the program itself. Like it's not built by you as a programmer, but it's already built by the programming language itself. And those variables can be anytime called in a program. So when you are learning a new computer language, you will always will have a chapter about what kind of common built-in variables are already available in that programming library. That's how you will get to know that, and it could differ per computer language. So the picture on the left hand side, it gives a beautiful view on how from inner to outer this whole scope of each type of variable has increased. Local scope, then then encompassing that is the enclosing one, and if we take it to the next level, it's global, and then the other one is the built-in one. So I hope that's very clear. So LEGP rule and the definition of each of the scope are very important. In this slide, we are going to see a couple of examples about the 4 types of variable scope. The example you see on the first small box is a very simple example. It talks about how when you declare a variable x as 0 in a global location, how it can behave. And then there is another function called def outer. Um, and then you can see x is equal to 1, and which also can become an enclosed loop when you declare another subfunction def inner with x is equal to 2. So when a computer program executes this, first it will look into the local scope. So it will check, oh, okay, x value is 2. And then when as it loops through, it value may get shifted to x is equal to 1. And then as it comes out, when you want to even refer any global variable, x can become 0 as well. So it depends on the programming language, as well as the logic and the algorithm you have written. The computer program will know to use the exact value of x when needed. The right hand side example is the best one. In this example, I've declared a variable called greeting as hello, and in the global scope location. So anywhere inside a program, and if you just call greeting, it can give you a value of hello. But what's happening is I've also declared 2 different small functions. And first function is called change greeting. Inside that there is a new underscore greeting variable declared. And in the second line, I'm saying, okay, global greeting. So call the greeting here. So that means if you print at that stage, print greeting, you will see a value of hello. Anyway, now at that point, global greeting, I'm saying treat this greeting variable as global, and then now greeting is also equal to new underscore greeting. So whatever value new underscore greeting will get, allocate that value to greeting. That's what you are telling the computer program. And as the program continues, in the next function, you can see greeting underscore world. There is no variable in the brackets, but we have declared a variable called world and assigned a value called world. Now, when you print greeting and the world, that's what you want to do. At that point, the greeting will possibly have the value of hello, and then the world value will have got world. So it would be hello world. But next statement I've got change underscore greeting, and I'm passing a variable of hi here. What I'm saying at this point is, okay, change the value of new underscore greeting to hi now. And then in the second line, I'm calling the function of greeting underscore world like one more time. And if you print this again, the answer finally you can see that is hi world. If you have not return the last 2 statements like change underscore greeting hi and greeting underscore world, I'm pretty sure the answer would have been hello world. So if you are interested, you can write this program in your computer and try it out. Okay, so we are going to now move into a different topic, which is module. Let's see what's a module. Your module is nothing but it's a part of a program. The programs are normally composed of one or more independently developed modules. Modules can also work individually and can also be integrated with other modules too. So the concept of actually module is quite similar in any programming language. So it's nothing but a simple process of subdividing a large computer program into separate subprograms. And that particular process is called modular programming. It's good to remember this definitely, because you may get questions on this. This also enables programmers to divide up the work and also debug issues independently. I spoke about writing subroutines or writing smaller programs because as it helps the compiler of the computer to process things faster. And not only that, when you are writing modular programming, when you are using modular programming techniques, it helps to debug your each subset of code easily, instead of writing like hundreds and hundreds of lines of one single code and calling it as a single function. It is always good to cut into smaller pieces. And the general examples are, we already spoke about subroutines and functions and procedures. So sometimes it is confusing, because if you think about subroutines and modulars, it's almost similar concept really. It's all different terminology and how it is used. It's also important to memorize or remember the characteristics of modules, because they are fundamental to a module concept. So the first one being, modules contain instructions and the processing logic as and the data with it. When you say data, it's about, for example, if you're doing an addition 1 plus 2, then 1 and 2 are the data you are using in that particular program or the module, sorry. And modules can also be separately compiled and stored in a library. You can also build a module and put it in a library. So the benefits of doing that is, the moment you put a module into a library, the library suddenly become more kind of global function, and you can call the such library from many different subprograms or modules. Modules can be included in a program, which we already know, because any program will definitely have reference to a module, any large program. Module segments can be used by invoking a name and some parameters. This is quite common, it will, similar to function, it will have a name and set of parameters uh, to use to call that particular module. And module segments can be used by other modules. This is similar to nesting concept, because within a module you can also call another module which is performing some repetitive task. So again, it's the concept is almost similar to subroutines, but it is a kind of subroutine. Um, but general terminology used in computer programming world is modular programming. Okay, so just remember the points of around its characteristics, which is important. So what are the benefits of using modules? Which is quite obvious in general. We have seen even examples before about smaller codes. So less code to be written and keep it simple and easy to understand. And as I said, you can use some simple procedures slash module, which can be developed for reuse. Meaning, let's say you have a particular function you want to constantly call it all the time, so you can just put them in a simple module and give it a name and and along with parameters, and whenever wherever you need it you can call it. And so in such scenarios it will be mostly the module will be stored in as a library as well. Modular programming helps many programmers to collaborate on the same applications. That is 100% true, because when you're having a project in computer job, one programmer cannot build everything sometimes, depending on the complexity of what the program is supposed to do. There could be more than one programmer working on a solution. So what we do normally is divide it into, let's say, 5 to 6 modular programming, and each person may work on one logic, and that itself could be hundreds and hundreds of line. And when we do this kind of co-working, this is where the global parameter declaration helps, as well as the library concept helps, like writing single procedures for reuse, and then also slicing a larger problem statement into smaller subsets does also happen in such scenarios. And the code is also stored across multiple files. So because if you're writing, let's say, 5 modules or 5 subroutines slash programs, it will be stored as individual files as well. And errors can be easily identified, because normally when multiple developers are working on their own particular module, they will do a testing as well once the program is done. So they don't need to wait for another person's module to finish. They can independently test it, and then finally when all the modules are ready, then they do final end-to-end test. That's how it normally works in our computer jobs today. And same code can be reused many applications. So that's important. So what is many applications? So there could be many different solutions you may build for a company, for example. So if you do that, you may not need to write the same module again and again and again. So once you build some solid modules, you can also reuse them in future for another solution you want to build for a particular customer at work. And scoping of variables can be easily controlled. Yes, obviously you can do a proper scoping, local, global, all kind of types. 4 types we learned, we can easily apply that. And obviously when you have programs can design more easily, since a small team deals with only a small part of entire code. Yes, that is true. It helps to prevent unnecessary failures. And even one person's module doesn't work, that doesn't stop the second programmer's work, and work keeps continuous until we finish, without while the other person can fix the issue as well. So I recommend that you definitely memorize the benefits of a module, and as you do more programming in your life or a job one day, you'll understand how to write a module, how to call the module, and also how to repeatedly use it when needed as well. Okay, so hope that helps. In the last topic, I want to cover and finish it off is access control. Okay, so access control is a very vast topic in computer field, but they've just touched on minor sub topic around this in your book. So I'm going to try my best to explain some of the basic concept around it. Okay, access control is nothing but a security technique that regulates who or what can view or use the resources, meaning the data, in a computing environment. It is a fundamental concept in security that minimizes a risk to the object. So what does this mean? So when you do programming, you are obviously doing programming to solve a problem. That's fine. But when such problems solving programs are ready, you can also control the access of that program's results by different types of access control methods. So for example, when you're defining a class, you can also say it can be either public or private or protected. The moment you define that, that particular class will decide who can see what, who can even see what data, who can run even the program, and who cannot run the program. So it has that kind of power. It's very commonly used to practice in computer programming because it helps to protect the data of who a person can see in an application. So I will give more examples about it in a moment. So the three types of access controls which you need to remember are private members, public members, and protected members of class. So what is private members of a class are normally denied access from outside the class. So when only if you are given an access to a particular class, you can only see what's happening inside the class, and you can only execute that class to see a result. Part and so let's say I am a programmer and you are a programmer too. So when I'm given access to as a private member, then I'll be able to see that particular class. But if I'm not given the access, I cannot even call that class in a computer program. So similar to that, actually, if you take that concept opposite way, public members are accessible from outside the class. So what does that mean? When you declare a class as public, like when you it's almost similar to a global level. Every time from any function or a module you are calling that class, you will find a value, you will get a value or whatever output it gives you. But if you're in that scenario, if that class is a private class, then you will not be able to access it unless you're given permission for that. The protected one is the highest security. These classes are accessible only from within the class and are also available to its subclasses. So it's kind of similar to private members, but concept. But it in a computer programming, you can put extra protection in such a way that literally one person can see that, or only that class can even feel what data it can give. So I would not spend more time on this because you will know more as we learn more chapters in coming units. But it's important to know the definitions between sorry, it is important to know there are three types involved in an access control for classes, and just understand that it's mainly used to it's a security technique that actually helps to regulate who or what can view the class in a computing environment. Okay, so but actually Python doesn't have any mechanism that effectively restricts access to any instance variable or method. Normally in Python programming, all members in a Python class are public by default, whereas the default is private in other programming languages such as C++ and Java. So in those areas, there are explicit uh, um, definition or a declaration needed if you want to call a class as public. And any member can be accessed from outside the class environment in Python, which is also not possible in C++ and Java. Python is a little bit looser in those type of access control, but again, there are different ways to tighten that control. But the programming languages Java and C++ have specific declaration for the managing the access of the classes. And to finish this topic, why this is needed, again, why it is used and why it's needed, it helps to protect the data you see through a screen. Okay, so and sometimes in some computer, depending on a application you use, there could be requirements that some data cannot be seen by particular logged in person. So there will be different access control requirements there. So in order to support such things, these type of class concepts which can have different access controls are needed. But as I said, for now, it's very high level at this point in your book. So I think for now it is good to understand up to these levels. Okay, I think we discussed a lot in chapter 3. Hope it was useful. In next video, I'll be finishing up the chapter last chapter 4 of Unit 1, which is algorithmic strategies. We really touched less about algorithm in Unit 1, I would say, but this chapter really talks in detail about the algorithms and its efficiency concept, and how it helps in searching and sorting algorithms, and how a dynamic program works using this algorithmic approach as well. So speak to you soon in a next video, and please continue to watch the series, as well as share with the friends who would love to learn more about these chapters. Okay, you all have a good day. Thank you. Bye.